Math of Texas Hold'em Poker. Author Dr. D. Selzer-McKenzie. A World Series of Poker hand. The following hand occurred during the last 5 minutes of the first day of the $10,000 Championship No Limit Hold'em event. It is a good hand to illustrate proper no limit thought processes as well as a simple trick to estimate all-in odds. With 8 players at the table, the ante was $50 and the blinds were $100-$200. I was the small blind and had the moderate amount of $15,000 in front of me. A well-known tournament player had the big blind and about $5,000. I held pocket sevens and everyone folded to me. I made it $1,200 total. The player in the big blind moved in $3,800 more. Now what? Obviously, this problem combines both reading hands and mathematics. At this point I was getting 6,600-3,800 odds. I need to win 3,800/10,400 of the time to have an even bet about 36.5%. To know what my chances are, I need to know not only what my opponent's possible holdings are, but also how to turn that into an overall price. After some thought, I came to the conclusion that my well-known opponent did not need a great hand to move in this spot. I know he hates to risk all of his chips on close gambles, but 3 factors told me this situation was an exception, namely, my position, his relatively short stack, and the fact that he probably felt an aversion to returning the second day with very few chips. It was better to double up or get out. On the other hand, this opponent would not go overboard here. I thought he would choose only hands that had pretty good chances in a race even if I called him with a premium hand. I postulated that he probably had a pair of 5s or better, or A-K, or A-Q. Given that, would the pair of 7s win often enough to make a call correct? The reason why this question is not simple is because not all hands are equally likely to be dealt. A-K and A-Q can be dealt 16 ways, while pair can be dealt 6 ways, except for 2 7s, for which my opponent had only 1 way. So, even if I know the chances the 7s have against each of my opponent's possible holdings, I can't simply average them. I must instead get a weighted average, which is time-consuming. But here's a trick. First, I count the total number of combinations my opponent, in my opinion, could have. A-K plus A-Q is 32. Aces down to 5s is 55, 9, times 6 plus 1. That's 87. Now I add up how many of these 87 possibilities figures to win for me. When he has one of the 32 non-pair combinations, I should win about 17 of them. When he has one of the 12 combinations of pairs smaller than mine, I should win about 10 of them. When he has any of the 42 combinations of pairs above mine, I should win about 7. That's 34. I then add a half for when we both have 7s. Altogether, my chances are about 34.5 out of 87, just short of 40%. Since I rarely make borderline calls for big money in tournaments, where survival is critical, I was reluctant to call here. But I did. And in theory I was probably right, since my well-known opponent showed K-Q. Had I added that to his possible move-in hands, my chances would have increased to about 37.5 out of 93. Do you see why? That's more than 40%. If he also would have raised with other hands, especially pairs below 5s, my call was clear-cut. But that didn't stop it from coming a controversial play. Our books point out that there are sometimes situations, especially in multi-way pots, in which you should delay raising with a good hand. The idea is that by keeping the pot smaller and disguising your hand, you can get someone to bet into you the next round, allowing you to raise others out. Sometimes the scenario is that you bet to get someone else to raise. We have encountered criticism for that recommendation because it misses the opportunity to extract the maximum from worse hands. Critics say that it is better to raise on the earlier round and then come out betting on the next round. Unquestionably, that is often the better alternative. It depends on the exact situation. But we believe that our play has the higher expected value, EV, in more situations than most people think. Hopefully, the reader can see that the debate revolves around the fact that our play wins less money when it wins, but wins the pot more often. Is it worth it to give up profits to somewhat increase winning chances? That is normally a very complex question. So, what I want to do here is set up a very simplistic model that corresponds to the situation in a very rough way. Say the bet is $100 and you have a hand that is 60% to beat each of your two opponents. The first opponent checks, the next one bets, and it is up to you. If you raise, they will both call. On the next round, you will bet again and get called by both. So, after the first two rounds, each of you will have $300 in the pot. Assume nothing was put in earlier. The alternative play would be to just call the first round bet, then when it goes check, bet, you now raise. Assume the second round raise will get the first guy out. That leaves you heads up as a 60% shot. One opponent has given up $100 and the other has matched your $300. Of course, it isn't realistic to think that in a real game, your chances of winning will remain unchanged. It is easy to see that your EV with the second alternative, assuming no further betting, is 120. That's 60% of $400 minus 40% of $300. What about the first alternative, where you raise and bet out? In that case, you win less often. If each opponent's chances of beating you are independent, the chances that you beat both are 60% x 60%, or 36%. So, if they both contest you, your EV is 36% x 600 minus 64% x $300. That EV is a mere $24, which is much worse than if you got it heads up. Suppose you are 70% against both hands. Playing the pot three ways means you win $600 49% of the time, while losing $300 51% of the time. That's an EV of $141. Playing the hand heads up means you win $400 70% of the time and lose $330 of the time, or $190. It's still better to delay your raise to get the guy out. And this, don't forget, is true even though we assumed there was no previous money put into the pot. When you are a 4-to-1 favorite, 80%, against each hand individually, it is a different story. Now, it is better to raise on the first round to keep the guy in and win more money. That play results in an EV of 64% of $600 minus 36% of $300, or $276. The other way gets you 80% of $400 minus 20% of $300, which is $260. However, if the hand involved 3, rather than 2, opponents, each of whom had an independent 20% chance to beat you, the right play, under these simplified assumptions, again, is to delay your raise. If you don't, you will win $900 51.2% of the time and lose $300 48.8% of the time. See why? That's an EV of $314.40. If you wait to raise and get two guys out, you will win $500 80% of the time while losing $300 20% of the time. That's an EV of $340. Of course, this simplified model has quite a few flaws. The most important one is that in real poker, knocking out players will not usually result in as great an increase in your chances of winning as it does in this model. The chances for each opponent are not independent. This is especially true if your hand is not only the best now, but also has chances to improve to an inch. Other problems with this model stem from the fact that probabilities change from round to round, in real life, as does betting limits. These problems all mean that you need not be as strong a favorite as the model suggests to make it right to build the pot early. On the other hand, the model assumes no money was put into the pot on the previous round. If there is that much more reason to strive to win the pot at all costs, even if that means not building it further, thus making it easier to raise people out the next round. What this model does seem to show is the following: it may well be right to avoid building the pot early with rather good hands and multi-way pots if that decision will deceive a player on your right into betting into you on the next round, when he otherwise wouldn't. Exactly when you should do that will be discussed at another time. Examples are given in our Holdm poker for advanced players. For now, suffice it to say that the player is correct a lot more often than common sense might indicate. A common error. Consider the following four scenarios. 1. A professional gambler hires a renowned football handicapper to come up with picks for him to bet. The guy comes through with 59% winners. The gambler is pleased, but he knows that even 53% would show a profit. So, he asks his handicapper to be less picky about advising a bet. He wants to know, and bet on, those games that heretofore were not quite good enough in the handicapper's mind to make a play. 2. A loan officer at a bank is proud that 97% of the loans he has approved have been paid back fully. The bank president, however, knows they would still make plenty of money if only 95% of loans were paid. He therefore tells the loan officer to be more liberal when it comes to approving loans. 3. A casino manager notices that his $1 slots are winning an average of $200 a day each, while his quarter slots are winning $150 a day. He therefore starts replacing quarter slots with dollar slots until the per machine wins almost equal out. 4. A casino manager realizes that his poker room makes half as much per square foot as his slots. Thus, he closes his poker room and puts slot machines in its place. Perhaps you can see that these four scenarios have a lot in common. You might even realize that they involve similarly flawed thinking. If you don't, here's the following. 1. There is a good chance the handicapper is already giving out games that are 55% or less to cover the spread, because he is also almost certainly giving out games that are over 60% to cover. If the professional gambler insisted on the handicapper giving up more game picks, he might be costing himself money without ever realizing it. The overall percentage might dip down to 56% or so, where he still does quite well. But the extra bets he is now making could easily be, on average, losing ones. 2. This example is almost identical to the first one, except it should be even more obvious. That's because everyone knows that many loan customers are 99.9% certain to pay back. If half of them are, the other half are on average 94%, and some are thus worse. If the bank manager insisted on bringing the overall loan repay rate down to 95%, the loan officer would be forced to give out loans that were less than 90% certain to be repaid. If those loans are unprofitable, the bank would be needlessly costing itself money and, again, might never realize it. 3. Here, the mistake is not as obvious, but it involves the same principle. And it has nothing to do with the psychological aspect of appearing to give quarter players short shrift. More precisely, the principle is not to get average gain or loss confused with incremental gain or loss. In this particular case, adding more dollar machines might be the right decision, but it could easily be wrong, psychological consideration aside. To show this, let's say this casino started with only one quarter machine and $1 machine. Now, they are up to 5 each. But when they started, their one quarter machine won $190 a day while their dollar machine won $300. With 2 machines each, the average went to $180 versus $275. With 3 machines each, it was $170 versus $250. When they moved up to 4 machines each, the quarters averaged $160 while the dollars averaged $225. Finally, with 10 total machines, dollars beat quarters $200 to $150, which is the situation of scenario number 3. And it is at this point that the casino manager is planning to switch at least one quarter machine to a dollar machine. But if he was managing the hypothetical casino we were just talking about, it would be a dumb move. To show why, we need to look at the totals, rather than the averages. This shows that each succeeding machine adds less and less to total casino revenue, not surprisingly, unless the casino is always jam-packed. But look at the pattern of the incremental income. That 5th dollar machine adds less to the casino's revenue than the 5th quarter machine. The contemplated 6th dollar machine would add even less. In this example, a switch would be a big mistake, and probably in real life, too, since dollar machine players are less plentiful than quarter players. If a slot or casino manager wants to make sure he is allocating the proper number of denominations to the floor of a casino, he cannot simply look at averages. He must instead experiment with adding or subtracting a few machines to assess their incremental value. 4. As far as taking out the poker room to put in slots, most casino big shots think that may be wrong only because they want to have a full-service casino that accommodates all tastes. They don't realize that the fact that slots make more per square foot on average does not necessarily mean the casino would make more money from the slots that replace the poker room than it does from poker itself. That's too bad, because, as of now, most casino honchos think they are doing us poker players a favor by having that card draw on. But in all probability, they are doing themselves a favor. Ace in a race. It is the World Series of Poker and you are in it. True, you won a satellite to get in, and you know you are not a superstar. But you are no slouch, either. You have survived the first 6 hours, built your $10,000 to $12,000, and are now playing with $200-$400 blinds. Being a good, but not great, player, you know you have to gamble a bit. The very best players are trying not to commit lots of chips when they have only a small edge, but that is not your strategy. On the other hand, you have no desire to throw caution completely to the wind. You are willing to bet lots of chips with a small edge, but not otherwise. On the Other side of the coin, part of your strategy is to avoid confrontations with the best players, if at all possible. There are plenty of players in the tournament who play worse than you. So, you know you will feel sick if you get played out of lots of chips by one of the champions, especially if you have a hand you didn't have to play. As you are contemplating these thoughts, you look down to see the 8 in the small $200 blind. This is not usually a playable no-limit hand, but when everyone folds to you, things change because it is very likely you have a better starting hand than the player in the big blind. Thus, a raise, or at least a call, seems in order except for one thing. It is Phil Ivey who's in the big blind. Now what do you do? If you were low on chips, it would obviously be right to move them in and take your chances. But you still have plenty of chips, $12,000. Against weak players, you might try a moderate raise, but you don't like that move against Phil. He will probably call. Then what do you do if an ace doesn't flop, or, for that matter, if it does? Perhaps it would be better to just call the $200 except that you know Phil will often raise. And even if he doesn't, you still wind up in a similar situation out of position. With a tricky hand, against one of the best tournament players in the world. Thus, you remember your admonition to yourself about avoiding champions, and simply fold. As smart as that seems, I can prove your players wrong, because I can prove that moving in $12,000 is a better play than folding. Other plays may be better, but from a pure mathematical standpoint, folding can't be right because moving in has a higher expected value, EV. At this point you may be thinking that it is impossible to calculate the mathematical expectation of moving in, because you don't know what hands Phil Ivey will call with. That is, of course, true except that it turns out that it is right to move in even if Phil plays perfectly. In other words, he knows your hand and calls with all the hands he should and none that he shouldn't. Hopefully you see that it is correct to move in if Phil plays precisely A-8 to A-K, or a pair. It is even more correct if he folds some of those hands, or calls with others. It is surprising, but true, that with an A-8, you would need more than 70 times the small blind in your stack for it to be right to fold your hand, even if the big blind sees your cards. This statement does not take into account the bunching factor, the idea that you can assume the big blind's cards are better than random when everyone else folds. That's true, but computers have shown that the effect is negligible in Holdm. Here's the math. Assume $1-$2 blinds. Because the big blind is getting only very slightly above even money when you move in, it is correct for him to call only with pairs or a better or equal ace. Of the 1,225 draw card combinations he could have, only 141, or about 1/9, will he play. So, there is about an 8/9 chance you will steal the big blind by moving in. Now let's see what happens when you are called. With 45 of the 141 combinations he could have, deuces through sevens, plus A-8, he is about even money. With eights through kings, he is an average of about 70%. That's 33 combinations. The 3 combinations of aces are more than 90%. And the 60 combinations of bigger aces are about 75%. If you average these out, you get the big blind winning about 2 out of 3 times he calls. Suppose this situation came up 54 times. If so, you should steal the $2 blind 8/9 of those situations, or 48 times. Of the 6 remaining times, you will win your all-in bet, plus $1, twice and lose that amount 4 times. So, with X dollars to move in, your net result, after 54 hands, would be 48, 2, plus 2, X plus 1, 4, X plus 1. That result is better than folding as long as it exceeds minus 54, which would be your result if you folded every time. The break-even point occurs when 48, 2, plus 2, X plus 1, 4, X plus 1. 54. Simplifying, 2x equals 148, or x equals 74. With 60 times the small blind in fill IV, almost certainly folding A-10 and A-9 when you move in, your decision should be easy. Note, what you just read has some major implications, especially in a tournament. The fact is that any two cards can be rated according to their heads up, face up, all in value. The rating for A-8 is about 70. A-2 is significantly less. 2 kings are about 1000. I expect to be writing a list of ratings for all tarot card hands in the near future.